Okay, so what we're going to work on right now is chapter 6, section 1A. The reason, guys, that I broke this up is because our book, the Cengage book, chapter 6, jumps into trig, angles, degrees, and measurement, assuming that you remember everything you learned in geometry about angles in the degrees, and it jumps into another unit of measure that we use for degrees, which is called radians. And so I think that it's too difficult to jump right in to chapter 6, section 1, and jump into radians and arc measures and all these weird things, okay? So what I've sort of done is I've broken down lessons and kind of inserted pre-lessons. This is like a pre-lesson to our Cengage book 6.1. This is kind of a review of degrees, okay? There's a lot of vocabulary that I definitely think you guys are going to want to have memorized and learn and understand. Every time I teach you a lesson on degrees, the next lesson will be in terms of the other unit of measure called radians. So it's really important, guys, that when I introduce degrees, that you do that homework that night and you totally understand the homework using degrees, which is what you're used to, like a 90-degree angle, a 30-degree angle. For example, when we deal with angles, you guys have, your initial side, you have like the terminal side, let's say, and basically you know that an angle is created from two rays that meet at this common vertex. The degree is this right here, this space here, and it's about, let's say, 30 degrees, maybe that's 45 degrees, but that's how we kind of determine angle. We do it in degrees. You're familiar with some really common degrees, like, for example, a right angle, which you learned is 90 degrees, okay? So you have your first side, you have the second side, 90 degrees, no problem. Basically, you learned that an acute angle is an angle that is between 0 and 90 degrees. So it would kind of be in that space, again, like maybe this angle. This would be like 45 degrees because it's, about in the middle of this 90-degree angle. So you learned about 90-degree angles. You learned about acute angles. These angles here would all be acute angles because they're between 0 and 90. We further took the lesson at some point, and you guys did, let me kind of erase this out. You guys did a straight angle. You said, hey, what about an angle that has a vertices and the rays go in opposite directions? This angle here is 180 degrees. So you guys also learned how to do that. Anything that fell between 90 and 180, basically in this section here maybe, this would be considered an obtuse angle because it's more than 90 but less than 180. And so again, degrees is something that I think most of you guys remember, and I think you're probably pretty comfortable with. Now, do angles end at 0, 45, 90, 180? No, angles can be infinite. And that's what we're going to start talking about in the next sections, okay? You can have angles bigger than 180. You can have an angle that's 270 degrees. Let's kind of goes down here. Let's say I do this, right? An angle that goes like this is an angle. So in the next few slides, we'll talk about that. Up until now, one of the things that we've done a lot with is we've done angles that have been kind of free-form angles, not really like this picture here where my angles happen to be on a coordinate plane, okay? This is where a lot of the trig that we do, trigonometry meaning sine, cosine, tangents, different ratios that we learn about, we either learn about them in terms of, we put them in triangles, so we have degrees inside of a triangle, which is how you learned it in geometry, or we do it on a coordinate plane. So what we do is we create, remember, a coordinate plane basically has an x-axis and a y-axis, okay? And we sort of use 0, 0, the origin, as our vertex, okay? And so when we are doing degrees or angles in a coordinate plane, when we create those angles, we have to have a starting point. The starting point in a coordinate plane is always from a ray that goes along the x-axis here on this positive side, okay? So that red ray is always the initial side of your angle, okay? Now, the other side of the angle is called the terminal side. And so in this case, the terminal side would be this one. Okay, it's where the angle ends. So we have where it starts. It always starts in the same place. Now it doesn't always end in the same place. For example, this angle might be maybe a 40-degree angle. That's what it kind of looks like to me. But I might have an angle that starts again at the initial side there, and maybe the angle goes in this direction to here. Okay, can anybody give me an idea of what that angle might be? The initial side is on the x-axis. The terminal side is a little bit to the left of the y-axis up there. What do you think that angle could be?
120.
Yeah, that's a good guess. 100 degrees, maybe 120 degrees. But you know, right, this is 90 degrees here. This one's 180, so it's going to have to be some number between 90 and 180. So that was a great guess. So our terminal side isn't on this quadrant here. This is known as quadrant 1. Our terminal side here ended up being in quadrant 2. Our terminal side could end in quadrant 3, and it could also be in quadrant 4. We want to definitely learn the quadrants, because some of the questions I might ask you are, hey, in what quadrant is the terminal side? Okay, where does it end, in what quadrant? And so you're going to have to tell me, well, this terminal side ends in quadrant 2. Okay? Now, if you notice, this was a positive angle, and positive angles are really all you guys have dealt with in the past. Okay? You've really only dealt with positive angles most likely. Okay? So this is about maybe a 40-degree angle. Again, it's a guess, but it's about 40 degrees. We call it a positive angle because of the rotation. If something rotates counterclockwise, okay, counterclockwise from the initial side, it's a positive angle. So again, how does that work? I have my initial side, and if it's a positive 40, I know my arrow and my rotation has to go counterclockwise. I know we don't use old clocks too much anymore, but like our clock doesn't even work in this classroom. But the hands of the clock and the second hand, they turn clockwise, which is this way. Okay, so that's a clockwise direction. Counterclockwise means I'm going to the left in my rotation. Okay, and so a positive angle is this one. It's counterclockwise. You're going in that other direction. Okay, you could be given a negative angle, and the rotation would be clockwise. So again, if I give you a negative 40-degree angle, okay, it's the same size angle. If you look at this size right here, this space, it's going to be the same as this one. They're both about 40 degrees, but one is positive 40 and one is negative 40 degrees. And what makes it negative, guys, is the rotation. They all start at the same place, the same initial side, but I'm going to go 40 degrees in a clockwise direction to get to my terminal side. Okay, so that's kind of how, so when I ask you to graph an angle, I'm going to want you to show me the initial side. Notice the arrowheads, guys. They always have these arrowheads at the end. That's to remind you that angles are formed by rays. And the second thing is your rotation is going to have to be there. You're going to have to show me, how did my rotation go? In what direction? The arrowhead will show me the rotation. Okay, so I'm going to want to see these features, okay, if when you guys graph something for me. Okay, again, initial side, trying to get my little colors here, the rotation of the angle and whatever. Okay, so I would definitely want you to show me that. Now, again, angles don't just start and end in these 4 quadrants like with one revolution. You can have angles, guys, that do multiple revolutions. So let me try to draw for you guys. Let's try to do a couple more angles here, and you can do it on your paper. Okay, again here. What if I ask you to do for me a positive 400-degree angle? Okay, if I ask you to do positive 400 degrees, you're going to start with your initial side here with your little arrowheads, and positive 400 means counterclockwise rotation. Every time I hit, guys, the axis line, it's an extra 90 degrees. So this was 90 degrees. I keep going. This was another 90 degrees, so that takes me to 180. I keep going. This here is 270. and I keep going around, and I end up getting to 1 revolution. So I start at 0, and if I go 1 full circle, I'm at 360 degrees. Well, again, guys, if they want me to get to 400, I've got to do basically 1 revolution and 40 more degrees to here. Does that make sense, guys? Right? Because this revolution is 360 degrees, and then I have to go plus 40 more. So here's my initial side, here's my terminal side, and this is a 40-degree angle. Do I need to have the red, all the red showing the revolution? Not in WebAssign. If you check your answers, WebAssign's just going to have the blue angle there. But for me and on our assessments, you are going to have to show me the rotation, that you started at the initial side, you did 1 revolution, and you went 40 more degrees up to 400 degrees. Okay, I need to see the revolution with the arrow and everything. When you do your homework in WebAssign, it tells you specifically, you're not just selecting the correct graph, you're going to Notability, you're drawing it in Notability, and then you're going to match what you drew to what's here. Okay. What if I have, guys, a angle and I tell you to do a negative 230 degree angle? Okay. If I have negative 230, what are we going to do, guys? Oliver, where would I start? Where's my first line?
0.
Yeah, I'm going to start here at 0 like that, right? My initial side is going to kind of go like that with my arrow. And then I'm going to move, because it's negative, I'm moving clockwise. So I'm going to go 230 degrees in this direction. So that's 90, that's 180, and I got to go 50 more here until I get to this terminal side right there. So this would be about a negative 230 degree angle. Does that make sense, guys? You can use your axis lines as your guide. Every time you get to another axis line, you went an extra 90 degrees. Okay? All right. So what we're going to ask you to do is we're going to ask you, not only are we going to ask you to graph a negative 230 degree angle, a 200 degree angle, we're going to ask you also to find coterminal angles. And so what coterminal angles mean is these are angles that have the same initial side and the same terminal side. In other words, they start in the same place and they end in the same place. However, coterminal angles have different numbers of rotations. So just like, guys, in that last drawing, if you noticed, I told you to do negative 400 degrees. Well, you guys, or what was positive 400, right? So I had you start here, and you went 360 plus an extra 40, and you ended here. Okay, so I'm going to put in blue. This is the terminal side, this is the initial side, and this was a 440 degree angle. No, it wasn't 440, right? It was 400, right? Yeah, 400. Okay, that's a 400 degree angle, because I showed you the revolution. Well, guess what? A 40 degree angle, if I'm going to draw that, a 40 degree angle would also have that exact same beginning and end. Okay, so 400 degrees and 40 degrees are what we call coterminal, because they both start here on the initial side and they both end here on the terminal side, and they form the same space here. It's just that 400 did 1 revolution to get there, and 40 didn't do any revolutions, okay? So believe it or not, guys, you can have multiple, actually you can have an infinite number of angles that start and end in the same space, okay, and the same place. So if I want to find all my possible positive or negative coterminal angles, what I would really need to do is just add 360 degrees to the original angle, or subtract 360. Why would I add 360, guys? Or why would I subtract 360? Why is 360 picked? Yeah, exactly, because 360 is 1 full revolution. So it's going to get me, if I go 360 degrees from here, it's going to get me right back to the same spot, whether it's positive 360 or negative 360. I'm going to get to the same terminal side. Yeah. So instead of having to draw these out every time, all we're going to ask you to do is we're going to ask you to mathematically find those coterminal angles. So let's say I had 400 degrees and I want to find another coterminal angle with 400. If I want a positive one, I could add 360. And I'm going to get 760 degrees. Guess what? That's going to end. It's going to start and end in the exact same place as 400. I could also subtract 360 from 400 if I want to do it that way. 400 minus 360 is 40 degrees. That's another positive coterminal angle. And if I keep subtracting 360, guess what? I'm going to find another coterminal angle, but this one's going to be negative. So negative 320 degrees also ends and starts in the same place. And if you need proof of that, we could draw it out. Negative 320 would start here, and it would go 320 degrees this way, and it would end there. And if you notice, it has the same and start and end. It's just a negative angle. Okay? So that's what we're going to be focusing on. So here in these examples, we've got, again, these 4 angles. They want you to find 2 coterminal angles. Now, there's an infinite number of these. So there's not one right or wrong answer. I know I'm going to have my calculator and check because you guys all might come up with different ones. Okay? So for 908, I could take 908 degrees and I could add 360 to it, and that's going to give me 1268 degrees. Make sure you're using the degree symbols, guys. But 1268 is definitely one positive coterminal angle. I could have also gotten smaller. I could have said, okay, I'm going to start with 908, but I'm going to subtract 360. I'm still going to get a positive angle, but it's a little smaller. Instead of going bigger, I'm just choosing to go smaller. So 908 minus 360, I'm going to get 548 degrees. So that's another positive coterminal angle. I could subtract 360 from this and keep going. I could get a whole nother coterminal angle. All of these angles start and end in the same place. Eventually, because the instructions want one negative and one positive. Right now, all I've found are positive, positive, positive. I found 3 positive coterminal angles. Either one of those would work. Okay? Now, if I subtract 360 at this point, I'm lucky because I'm finally going to get to my first negative coterminal angle, which is 172 degrees, negative 172 degrees. And I can stop there. If I keep subtracting negatives, negative 360, I'm going to get more. So all you have to do is take the angle given and add 360 until you get another positive angle or you get a positive angle, and subtract 360 repeatedly until you get to a negative. Okay? Let me do number 2 with you, and then you guys can do 3 and 4 on your own. Okay? So number 2, again, I have negative 75 degrees. I'm going to start, guys, by adding 360 to that. So negative 75 plus 360 degrees. You have a calculator, so it does not, don't try to do this in your head if you have a calculator, or do it in your head for practice, or do it like on paper, and then check it with your calculator. But 285 degrees is a positive coterminal angle to negative 75. And if I take the negative 75 and I subtract 360, I'm going to get a negative coterminal angle with it. So let me do the math here. Negative 435 degrees. So I answer the question because the positive coterminal angle is 285 and the negative coterminal angle is negative 435. And that's all I need to answer that question. So I want you guys to work on these on your own, and then we will finish them up together. And that'll be the end of it for today. Okay, so I'm going to start working these out so I can finish the video, and then just you guys can double check as we go, okay? So we start with negative 203 degrees. So I'm going to do negative 203 degrees plus 360 degrees. Again, the beauty is I do have a calculator, and you are going to have a calculator for this section. So I know that allays some of your fears. This is 157 degrees. That's one positive coterminal angle. And then if I take negative 203 and I subtract 360, then I'll get to my, so 203 and 360, I'll get to negative 563 degrees, and that's my negative coterminal. Did anybody get a value different than this? Is everybody okay with this? Yeah. So again, guys, like your test is going to be challenging in this section because trig's not easy. You know, I mean, we can make it try to sound easy and you can practice it, but it's a tough topic. You don't want to get points taken off for coterminal angles. These are some of the easier problems you're going to get where you have to graph an angle, show the rotation, what quadrant does a terminal side end in, or something like this. Guys, these are the questions you want to master so that when we do get to the ones that are a little tougher, there's some room for error there, okay? Again, when I'm at 699, I'll do 699 degrees. I can start by adding 360. That's always an option. 699 plus 360 is 1,059 degrees. That's one positive angle. Or I know that this is more than one revolution, so I know that I could technically subtract 360 and I'll still get a positive value. So I could have started at 699, that's probably what I would have done, and subtracted 360 from it, and I would have gotten to 339 degrees, which is also positive. And then from there, I would have subtracted another 360, which I know will then get me to the negative, which is negative 21 degrees. And once I'm there, now I've answered the question. I have everything they asked me for. One of these constitutes your positive, and this one can constitute your negative, okay? And that's the gist of it. So this is the lesson today, guys. That's it. Understanding degrees, understanding the direction of the revolution with positive and negative, drawing it out, learning your quadrants, learning the vocab, what's up, the initial side, the terminal side, and what does coterminal mean and how to find it. And that's it for today.